Hello, my dear students. Welcome to the subject of social science for the class 10th English medium, chapter 11th, India Water Resources, presented to you by Vitan sir. Water. There is water, hence there is life. So we can say that water is our life. Life cannot be imagined on the earth without the water because there is no other option for water. Entire biotic world uses water to sustain itself. Every living being lives on water. The prosperity of any nation depends on its agriculture, and agriculture uses the maximum amount of water in it. Water is also required for drinking, domestic uses, and in industries. Due to water shortage and due to the rate of and volume at which it is being used, we have a water shortage in India and on earth. It is necessary to use water sparingly, that means minimally. Water is a limited resource and no other resource can be used in its place, and therefore we need to conserve water. The sources of water. The first source of water is rainwater. The second is groundwater. The third is the surface water. We will discuss them in detail. The first one, rainwater. It is the original source of water. All the other sources of water on earth exists due to the rain. So we can say that rain is the most important source of water among all. Second is the surface water. That is the water which is on the surface of the earth. The water found on the surface of the earth, for example, we can say in the form of river, lakes, ponds, sea, etc. Among them, river is the main source of the surface water. Third is the groundwater. Groundwater basically means water which is in the underground system. It is one of the most important sources of water. It is created by the absorption of water in ground. Its volume is very huge. Northern plains of India has almost 42% groundwater. The southern plains and the eastern plains, we can say they have hilly and mountainous regions, so they have less amount of groundwater. Water resources and its uses. Irrigation, we can say about 84% of water in India is useful for irrigation. That is, about 1500 liters of water is required to produce 1 kg of wheat. Paddy, jute and sugar cane even requires more water than that. In 2nd century, the famous Grand Anicut Canal, as in the picture depicted here, was constructed across the river Kaveri. In 1882, the Eastern Yamuna Canal was constructed in Uttar Pradesh. That means the water is used for irrigation purposes to give water to the fields, and it is also used for the saving purposes, for the charging of the earth purposes through the canals and the dams. The mediums of irrigation, that means how the irrigation is done. Number one, through wells and tube wells. Number two, canals. And number three, ponds. Basically means not just ponds but the farm ponds. We will discuss the first one, that is canals. Canal irrigation is used in the plains of Satluj River, Ganga, Yamuna and delta regions of Mahanadi, Godavari, Kaveri, Krishna, etc. rivers. In this picture you can see a canal. Canals are created out of rivers to provide water to faraway places. Wells and tube wells are used in regions with alluvial soil. Because alluvial soil can store water properly, so wells and tube wells are built in that soil to drain water from the ground. So these are used in fields and in farming and also in industries and sometimes in domestic purposes. Last, irrigation by ponds. As you can see in this picture, a small pond is created in the farm itself. So irrigation by ponds or farm ponds, or also known as khet talaudis, is seen more in the eastern and southern states like Kerala, Tamil Nadu, etc. These states, the farmers from these states build ponds in the farms itself. That ponds collect the water, charge the ground so that level of underground water increases. So automatic irrigation facility is provided to the farms in that manner. Multi-purpose projects. Multi-purpose projects are created for so many different purposes. For example, in this picture, if you see, based on the multi-purpose project, water is supplied to the industries, fishing can be done, hydropower, electricity is created, irrigation is helped, and again flood control is done, and the transportation by water is done through the multipurpose project. It means to solve various problems related with the river valleys. It includes flood control, prevention of soil erosion, water for drinking and irrigation industries, settlements, generation of electricity, transportation, entertainment, and wildlife protection. So with the multipurpose projects, we can do these many things. Major multipurpose projects of India. Bhakra Nangal Dam, situated at the Satluj River in Punjab, Haryana and Rajasthan. Kosi Dam, situated on Kosi River in the state of Bihar. Damodar Valley Dam, situated on Damodar River in Jharkhand and West Bengal. Hirakud project on Mahanadi in the state of Odisha. Chambal Valley project on Chambal River in the states of Madhya Pradesh and Rajasthan. Nagarjun Sagar Dam on Krishna River in the states of Andhra Pradesh and Telangana. Krishnaraj Sagar Dam on Kaveri River in Karnataka and Tamil Nadu states. Tungabhadra Dam on the Tungabhadra River in the state of Karnataka and Andhra Pradesh. Narmada Valley, that is Sardar Sarovar Yojana in the Narmada River, distributed in the states of Madhya Pradesh, Gujarat, Rajasthan and Maharashtra. Kadana Wakabori dams built on the Mahisagar River situated in Gujarat. Ukai Kakrapar Dam situated on the Tapi River in the state of Gujarat. Dharoi Dam on the Sabarmati River situated in the state of Gujarat. Distribution of area under irrigation. The irrigation is not uniform in the whole state. So we have to discuss which states have higher area under irrigation. In case you are wondering what is irrigation, irrigation is a facility of giving water to the farms using mechanical instruments. There is a difference regarding the area under irrigation in every state. Coastal districts in Andhra Pradesh, delta regions of Godavari and Krishna rivers, Mahanadi Delta in Odisha, Kaveri Delta in Tamil Nadu, Punjab, Haryana and Western Uttar Pradesh are regions with intensive irrigation of the country. That means these regions have very high level of water supply due to the big rivers and also due to the natural rain. The irrigated area in India has increased 4 times after the irrigation. Today, irrigation is practiced in 38% of the net sown area. Means the area sown, out of the total area sown, 38% has the irrigation facility. There is a huge difference in the irrigated places in the different states. In Mizoram, only 7.3% area of the total area sown is under irrigation, while in Punjab this percentage is 90.8. So there is a huge difference in the area irrigated according to states. The difference between the total area under irrigation with the total area sown, there is a huge difference. More than 40% of the total area sown is under irrigation in Punjab, Haryana, Uttar Pradesh, Bihar, Jammu Kashmir, Tamil Nadu and Manipur, while the remaining states have this area at a very less percentages. Water crisis. Now the water crisis we can understand better with a small clip. So in the next slide I will show you a clip based on the water crisis experienced in India as well as on Earth.
From space, our planet appears to be more ocean than Earth. But despite the water covering 71% of the planet's surface, more than half the world's population endures extreme water scarcity for at least 1 month a year. And current estimates predict that by 2040, up to 20 more countries could be experiencing water shortages. Taken together, these bleak statistics raise a startling question. Are we running out of clean water? Well, yes and no. At a planetary scale, Earth can't run out of fresh water thanks to the water cycle, a system that continuously produces and recycles water, morphing it from vapor to liquid to ice as it circulates around the globe. So this isn't really a question of how much water there is, but of how much of it is accessible to us. 97% of Earth's liquid is salt water, too loaded with minerals for humans to drink or use in agriculture. Of the remaining 3% of potentially usable fresh water, more than 2/3 is frozen in ice caps and glaciers. That leaves less than 1% available for sustaining all life on Earth, spread across our planet in rivers, lakes, underground aquifers, ground ice, and permafrost. It's these sources of water that are being rapidly depleted by humans, but slowly replenished by rain and snowfall. And this limited supply isn't distributed evenly around the globe. Diverse climates and geography provide some regions with more rainfall and natural water sources, while other areas have geographic features that make transporting water much more difficult. And supplying the infrastructure and energy it would take to move water across these regions is extremely expensive. In many of these water-poor areas, as well as some with greater access to water, humanity is guzzling up the local water supply faster than it can be replenished. And when more quickly renewed sources can't meet the demand, we start pumping it out of our finite underground reserves. Of Earth's 37 major underground reservoirs, 21 are on track to be irreversibly emptied. So while it's true that our planet isn't actually losing water, we are depleting the water sources we rely on at an unsustainable pace.
After having a look at the water crisis, let's see what we can do for the management and the conservation of the water resources. Again, I will show you a small clip based on this topic.
On average, people only drink about 2 liters of water a day. But water plays a hidden role in our daily lives. And in that same 24 hours, most people will actually consume an estimated 3,000 liters of water. In fact, household water, which we use to drink, cook, and clean, accounts for only 3.6% of humanity's water consumption. Another 4.4% goes to the wide range of factories which make the products we buy each day. But the remaining 92% of our water consumption is all spent on a single industry: agriculture. Our farms drain the equivalent of 3.3 billion Olympic-sized swimming pools every year. All of it swallowed up by crops and livestock to feed Earth's growing population. Agriculture currently covers 37% of Earth's land area, posing the biggest threat to our regional water supplies. And yet, it's also a necessity. So how do we limit agriculture's thirst while still feeding those who rely on it? Farmers are already finding ingenious ways to reduce their impact, like using special irrigation techniques to grow more crop per drop and breeding new crops that are less thirsty. Other industries are following suit, adopting production processes that reuse and recycle water. On a personal level, reducing food waste is the first step to reducing water use, since 1/3 of the food that leaves farms is currently wasted or thrown away. You might also want to consider eating less water-intensive foods like shelled nuts and red meat. Adopting a vegetarian lifestyle could reduce up to 1/3 of your water footprint. Our planet may never run out of water, but it doesn't have to for individuals to go thirsty. Solving this local problem requires a global solution, and small day-to-day decisions can affect reservoirs around the world.
Next, we are going to discuss watershed development. But for that, what is watershed? Understanding that is very important, as well as we also have to see how it is developed through a small clip.
Watershed development is the treatment of the entire catchment area around the village to ensure conservation and regeneration of all its natural resources, especially water.
Watershed development must be done from a ridge to valley basis. Right from the top, you dig continuous contour trenches. As you come lower, on wastelands, you dig continuous contour bunds. On farmlands, you erect farm bunds. Along the drainage line on the rivers, right from the top, you do gully plugs. As you come lower down, nulla bunds, gabion structures and check dams. The idea is to control soil erosion and to control the flow of gushing water. Water that is running, we try to make it walk. Walking water, we stop. Stopped water, we try to force it underground. The idea is to trap and harvest and store rainwater wherever it falls within the area itself. Since the speed of rainwater is controlled and the soil is not washed away, the rivers do not get flooded or silted. Thus, watershed development is an answer to two problems, that of drought and that of flooding.
Earlier efforts of watershed development concentrated merely on water harvesting structures and ignored treating the watershed as a whole. This led to soil erosion and therefore siltation of the structure. While there have been other schemes of poverty alleviation through environmental regeneration, this has been the first large-scale approach where people were not mere beneficiaries but actual owners and implementers of the project. They helped themselves by regenerating the environment they lived in.
Watershed development has a very important aspect, that is the rainwater harvesting. Rainwater harvesting, what does it mean and how can we do it? Again, I have prepared a small clip for you guys. After watching it, you will understand it better.
Rainwater harvesting. India, which is home to 16% of the world's total population, has access to only 4% of the world's total water resources to fulfill its water needs. This limited supply could easily deplete further or be made unusable by overutilization and population. Therefore, the need of the hour is water conservation, or what is referred to as water harvesting. Water harvesting encompasses all the different methods of conserving and collecting rainwater. One such method is rainwater harvesting and another is recharging groundwater. Rainwater harvesting involves either collecting the rainwater directly or recharging it to the ground to improve groundwater storage. And how does rainwater harvesting benefit us? It raises the groundwater level, checks rainwater flow, which prevents soil erosion, prevents rainwater pollution, and helps meet water demands during the dry season. And all of this can be accomplished with nothing more than house rooftops to collect the water and small PVC pipes to channelize the water into underground pits and sumps. Recharging groundwater is the modern version of rainwater harvesting. In this, pits, trenches and dug wells are constructed to collect water. The collected water then feeds and raises the level of groundwater. Did you know that rainwater harvesting is an ancient Indian tradition dating back to 4500 BC? Yes, in fact, it has been practiced for hundreds of years in Assam, Karnataka, Gujarat and Rajasthan. This ancient tradition was given a much needed impetus by the Government of India with the formulation of the National Water Policy, a policy that provides for the optimum and judicious utilization, management and conservation of India's water resources. The aim of this policy is to link river basins and then transfer water from one basin to another for the optimum use of the available water. The National Water Policy also exhorts the general public to assist the government in its mission to conserve water so as to minimize our water woes.
Now, understanding the rainwater harvesting, let us understand that objectives of rainwater harvesting one by one. First one, to increase the capacity to conserve the groundwater. That means capacity of the groundwater is increased through rainwater harvesting. You have already seen the video for that. To reduce the water pollution, improve the quality of groundwater, to save land roots from water logging. That means if we are doing the rainwater harvesting, the water will not be logged on the surface, rather it will be seeping in the underground areas. Reduce the surface runoff of water. That means the surface running off of water should be reduced, rather it should be conserved in the land itself. Fulfill the requirement of domestic water during the summer and during long dry spells. Means sometimes there is a lack of sufficient rains and the summer is lengthened. At that time the water can be used which has been stored from the rain for the purpose of domestic as well as industrial uses. Fulfill the increasing demand of water. Make arrangement to store rainwater in underground tanks in multi-story residences in large cities, or arrangement should be made so that the water percolates in the ground. That means in underground tanks in the residences of the large city, underground tanks should be created where the water is stored, or if that is not possible, the open ground should be maintained where such facilities are to be implemented so that the rainwater can be percolated in the ground so that the groundwater levels can be increased. Let us see an example of a village which solved the water problem through the water storage. That is the Bedaj village of Gujarat. The so-called backward village of Bedaj, which is situated in the Arvalli district of the Gujarat, has understood the value of water and watershed developments. What they have done, they have converted the entire region which was very dry and arid in the past into a greenery by conserving 2.25 crore liters of rainwater. What they have done, they created an association of the villagers and solved the primary problem of water by cooperation of the social institutions. They created the village pond. It was only spread in 7 vigas, but it was deepened by 20 to 22 feet so that its water holding capacity increased. They created 10 check dams, 11 farm ponds and drip in 25 hectares. Drip irrigation is a method where minimum water is used. Pipelines in 10 hectares, deep ploughs, also the small dams were created. So due to all these things, the water surface runoff of water was reduced, the water was stored in the same land and it percolated into the soil so that the earth water levels increased. About 2 lakh cubic meters of rainwater was stopped and stored. About 154 viga of land in Bedaj area got the new facility of water supply. Milk production increased by 12.5% in 1 year. Water storage increased by 20 to 30%, due to which the farm production also increased. Today, zaid crops are ruffling in 136 viga of land of Bedaj. So this is how Bedaj village overcome the water crisis through watershed development, water storage, stopping the surface runoff of water, getting the rainwater harvesting system in line and making an association of the whole village. Now, let us understand some points for the sake of water management. First, use water economically. Here, whenever you are using water for toilet and wash basins, try to divert them towards a purifying plant and then reuse that water for gardens and vehicles so that you use less water and do more with it. Public awareness is very important. Try to participate in the water conservation and its skilled management. If possible, recycle the used water. Prevent the deterioration of water storage units. Wherever you are storing the water, try to keep it repaired and up to date. Wherever the pipes are damaged, immediately repair them so that water pollution is not spread. Save the reservoirs from pollution. Increase the use of all units of water harvesting structures like wells, tube wells, khet talaudi, etc. Also, keep a watch on those units which are using the groundwater. So what we studied in this tutorial, what is the importance of water, sources of water, uses of water, crisis of water and its solution, water management. So with this, I end my tutorial here. Let's hope you understood the importance of water, its sources, its uses, the crisis, and how to solve the water problem through water management and rainwater harvesting. Next time, we will be discussing the chapter number 12. Till then, stay tuned and see you soon, my dear students.